We are talking about functions, and to begin with, you need to know the definition of a function. The first thing is we have got what we call mapping, and it is from mapping that we get what we call a function. So mapping is just a relationship between two sets. For example, you have got a set X. Say X has got the elements 1, 2, 3. And then you can also have another set Y. And say it has got the elements A, B, C. So for this kind, let's say the element 1 is pairing up with the element A in the other set. The element 2 is pairing up with the element B. The element 3 is pairing up with the element C. This is a mapping, and we call this mapping 1 to 1. This is a 1 to 1 mapping. I'm going to put 3 of these. We can also have, let's say, the set X and then the set Y. I'll still put elements there and elements there. Let me also have another one X and Y, and then I'm going to also have elements there and elements there. So now let's say for another one, we have got 1, 2, and 3. Here we have got A and B. And then you see it like this. So for this kind of mapping, can you see that one element in the in set Y is having two elements in set X. And then I can also have this 1, 2. And then here I've got A, B, C. And then say we have got this. So for this second one, because you have got two elements on the set that is at the beginning, going to 1, we call this as a many to 1 function or relation, many to 1. And then this one, because we have got one element pairing to 2, we call this one as a 1 to many. So all these guys that you can see here, we call them relations or mapping. Now, when you have got a one to many relation or mapping, this is not a function. So this is what you need to know about these relations. A one to many relation is not a function. And the set of x values that we start with in a mapping, we call them the input. We also call them the domain. So domain refers to the set of x values for which the function is defined. And then here you have got the product, we call this as the output. The set of x values, the set of y values for which the function is defined is known as a range. So you'll be hearing of terms like domain and range. Find the domain, find the range. If they say find the domain, they're saying find the set of x values for which the function is defined. And then range is the set of y values for which the function is defined. Now, on the product here, I can say range or what we call codomain. So I'm going to remove the word range and I'm going to put codomain. Codomain is simply also referring to set of y values. So what is the difference between when do I use codomain and when do I use a range for y values? So let's now have another set. Say you have got set x. Yes, please. Does someone have a question? Please be free. Say you have got the elements 1, 2, 3, and then here you have got, say, A, B, C, D. So if this one pairs with this one, let's say the 2 pairs with the B, 3 pairs with C. So we have got this set. I can also have another set X and Y. And say for this one we have got 1, 2, 3, 4. And then we have got A, B, C. So say this one is pairing with that. This one is pairing with that. This one is pairing with that. Okay. So for this function that is on top, you can see the set of x values, we call it the domain. The set of y values, we call it the codomain. Codomain. Now in this case, for the first one here, we'll not refer to this set of y values as the range. Why? Because we have got an element here that is not been paired with anything in x. So this is a one-to-one function. Okay, it is one-to-one mapping and is still a function. When you look at the second set here, because all the elements that are in y have been paired by some element in x, we call this as a range instead of saying codomain. So in other words, the range goes into the codomain. You call the codomain as a range when all the values in the set y has been paired to some value in the set of x. Does that make sense? Have I left out anyone? Does this make sense? Is there any question? Okay. All right. So remember the statement that I've said. Yes, is that a question? Please feel free to ask if you have got a question. All right. Not don't wait until we have gone too far for you to ask. Ask when we still have, when we are still on a concept, so that you can be able to get it. So we have said that a function is a relation or a mapping is going to be a function. How? When number one, all the elements that are in x have been paired to something in the y, right? So all the elements in x should be paired to something in the y. And besides that, you need to make sure that your function is one to one. That is how we define a function, a relation to be a function. Now we also have got functions which we call on to and into. So you hear of such a function. This function is on to, or this function is into. So the meaning of that is when we say a function is on to, it means that you have got an element like here in x that doesn't match up with anything in the y. Yes, please. Is that a question? Okay. So where have you been left out? Okay. Hmm. On the what? Okay. So what we are saying is when you have got a relation, right? When you have got a relation such that it is not one to one, but it is, let's say this function was like this. One x value is going to two y values. We call this as a one to many. A one to many relation, we are saying, is not a function by definition. Okay, the one to many is not a function. And then we also have a function that we call onto. So a function is onto if you have got an x value that is not paired to some y value. That's when we say that that function is onto. Okay. Now again, besides that, for you to so there are two things that make a relation not to be a function. Number one, if it is so relations that are not functions, one to many. One to many relation is not a function. And then can you see this one? A relation that is onto is not a function. So by definition again, if you see an x value that doesn't have any y value, such a relation is not a function. Okay, so if a relation that is onto is not a function. I hope this makes sense. Have I left out anyone before we move out of this? Okay, I believe that is okay. So the way you can find some questions, when I was in first year some 4 years ago, the in my test one, they gave us a question which was like this. They gave us a set A and then something like 1 comma 2, and then you have got 2 comma 3, and then there's 2 comma 1, and then they told us to say map this relation and then determine if the relation is a function. So how are you going to map this one? Put the x values and then put the y values. So for the x values, you only write an x value once, don't write it. I mean, if you are having an element, just write it once. So what are the x values that we have? We have got 1, 2, 2. So we only have 1 and 2. How about the y values? We have got 2, 3, and 1. So that's 1, 2, and 3. You can see 1 is paired to 2. So it's like this. And then 2 is paired to 3. So it's like this. And then 2 is paired to 1. So it is like this. Now the first one, who can determine is this a one to one, many to one, or one to many relation? Anyone that can answer? Many to one. So our friend has said many to one. Do we all agree? Yes? One to many. Okay. John, you wanted also to say something? Okay. So this relation here is a one to many. So this is one to many. Now, anyone who can determine is this a function or not a function? Is this a function or not? It's a function. So Prince says it's a function. Prudence has said it's not a function. Let me now hear one more person. The one who is going to tell us. Yes. Yes, so this one is not a function. Remember, when you have got one x value going to two y values, such a relation is not a function. Now, the way you remember this so that you don't get confused, a quadratic function is a function. And a quadratic, you have got one x value, two x values for one y value. So a quadratic is something like this. Mm, Let me just make a graphical representation of a quadratic function. Here are the x values. There are our y values. So a quadratic is like this. So you see this function. If I make a cut, like if I cut here, this is one y value, but it has got two x values, this value here and this value here. So a quadratic function, one y value can have two x values and it's still a function. But if you find the inverse of this function, the way the inverse looks like, it looks like this. The inverse looks like this. So if you make a cut here, you see that you only have one x value at this point, but you have got two y values here and also here. So the inverse of a quadratic function is not a function. Now let me not go ahead because I'm supposed to talk about also the inverse of a function. So this is what I wanted you to understand so that you don't forget that a 1 to many is not a function, a many to 1 is a function. Just consider a quadratic is a many to 1. You have got two x values going to one y value and it's a function. Now, one important thing you need to understand about functions is what we call how do you determine if a function is one to one? Okay, how to determine that a function is one to one? Because we've already looked at how it is. So now, the first thing you need to understand is this. If you say a function is one to one, okay, if you say a function is one to one, let's say this is a set of x values, this is a set of y values. If I say this is 1, this is 2, and then let's say this is a, and then this side we have got say I, j, and then okay, I can have I and j like that. So if I say this function is one to one, if I say that 1 is pairing with I, and then I say that 2 is pairing with j, and then I say a is also pairing with j. If this function is one to one, it means that a is also 2, because for a one to one function, the only number that can pair with j is a 2. You can only have one number pairing up with one other thing or one other letter. That is the meaning of one to one. If 2 is pairing up with j and then some other thing is pairing up with j, just know that that other thing is also a 2, because it's only a 2 that can pair up with j if this function is supposed to be one to one. I hope I haven't lost out anyone. So now, how do you prove that a function is one to one? If you've been given a function f of x, let's say f of x is equal to x plus 1. What you want to find is if I get A, I put where there is x. I get B, I put where there is x. And then the answer that I'm finding is giving me the same thing. It means that those two things that I've put where there is x are the same. Just like I said, if I get the function, I put 2, it gives me j. And I get a, it still gives me j. It means that that function is a one-to-one function. Why? Because when I got 2, I put in that function, and I got a, I put in that same function. It was giving me the same result. So that is the principle. So how do we show that f of x is equal to x plus 1 is a one-to-one function? What you do is find the f of a. So f of a is going to be equal to, where there is x, you are going to put a. So that is going to be a plus 1. And then also find f of b. So f of b is going to be equal to, we're in the same function, but now where there is x, we are putting b. So that is going to be equal to b plus 1. So we are supposed to equate f of a and f of b. So you say f of a is equal to f of b. Remember, what is f of a? It is 1 plus a plus 1. F of b is b plus 1. If I take 1 the other side, it will cancel with this other one. So just remember that a is equal to b. So you see, when we got a, we put in the function, and when we got b, we put in the function. Can you see that the result is the same? We've just concluded that a is equal to b. So how do you conclude? So you are going to say, since f of a is equal to f of b, gave us a being equal to b. This means that the function is 1 to 1. This is the conclusion you make. Since f of a is equal to f of b is produces a being equal to b, then the function is 1 to 1, because a and b are the same. Like the results are the same. It means that we got two different values, right? And then we put in the function. The results came out the same. That means that that function is 1 to 1. Just so that you understand, let's say you've been given that f of x is equal to x plus 1 over 2 plus x. They say show that this function is a 1 to 1 function. How are we going to do that? What you simply do is show that f of a is equal to f of b. So I'm going to say that f of a is equal to f of b. So get a where there's x, put a. So that will be a plus 1 over 2 plus a is equal to, now for the second part, where there's x, put b. That is going to be b plus 1 over 2 plus b. At this point, I want to make sure, remember, the aim is for me to show that a is equal to b. So cross multiply. So this a is going to multiply with a 2. That gives us 2a. The a again on top is going to multiply with a b. That is going to be ab. And then the 1 now will multiply with a 2. That is going to be 2. And then the 1 will multiply with a b. That is going to be b. And then this is going to be equal to, now we start this 2 down, will multiply with a b on top, that's going to be 2b. This 2 again down, will multiply with a 1 on top, that is going to be 2. And then the a here will multiply with a b on top, that is going to be ab. And then the a will multiply with a 1 on top, that is going to be a. And then what we want to do is take the like terms to the same side. So if I take 2, which one? Okay, not the 2a. If I take AB, the other side, it will become negative, so it will end up cancelling with this AB. If I take this to the other side, it will end up cancelling with these two because they have got opposite signs. I'm going to get this A, will take it the other side, so it will be 2A minus A, and that will be equal to, we have got 2B this side. I'll get this to B, take it the other side to be minus B. So 2A minus A, that is A, 2b minus b, that is b. So we'll conclude, since f of a is equal to f of b produces a is equal to b, that means that the function is 1 to 1. So how about if a function is not 1 to 1 and then they ask you to show that it's 1 to 1? How are you going to show that it isn't? So let's say, for example, a quadratic function is not 1 to 1. Let's say they've given you that f of x is equal to, say, 3x squared. They say show that this function is 1 to 1, or show that it's not 1 to 1, or prove if it is 1 to 1 or not, however they ask the question. So what you want to do is say f of a is equal to f of b. So get the function where there is x, put a. So this is going to be 3a squared, and then where there is x, put b, 3b squared. Divide both sides by 3. So that will be a squared is equal to b squared. Is that a question? Martin, you have a question? Okay. Now, if you have got a squared is equal to b squared, What you want to do is square root both sides. Okay, when you square root both sides, you are going to have a is equal to plus or minus the square root of b squared, like the square and square root to cancel, square and square root to cancel, so that will be b. Like this is the same as so. If you have got a squared is equal to 4, how do you solve this from your high school? Remember, a squared is equal to 4 is the same as a squared is equal to 2 squared. And the way you solve it is you square root both sides. And you are going to find that a is equal to positive or negative 2. That is the same thing with here. So the answer is positive or negative b. So a is equal to positive or negative b. So can you see that a is equal to b and a is equal to negative b? So a is not only giving us one thing. In other words, this is not a one-to-one function. Why? Because a is not only giving us one product, but it's giving us two products. It's giving us positive b and negative b. Does this make sense? Is there anyone that is left behind? Anyone that is left behind? Okay. Let me give you one more example so that we'll not have any complaint. So let's say we have got f of x is equal to, say, 4x squared plus x minus 1. They say show that this function is not one to one. It's quadratic, so it can be one to one. So again, say f of a is equal to f of b. Where there is x, we'll put a first. So that will be 4a squared plus a minus 1 is equal to, again, where there is x, put b. 4b squared plus b minus 1. At this point, what will happen is that if I take the ones to the same side, if I take one, the other side will become positive. So it will be 1 minus negative minus 1. Those will cancel out. So they are gone. We have remained with 4a squared plus a is equal to 4b squared plus b. Okay. This is what we have at this point. And we want to solve for any one of the letters that we have here. Now, the way you can see this one is I've got a square function this side and then also the other side, but we also have b. Okay, we also have another letter. So what we want to do is to make any one of the letters a subject of the formula. So if I try to factorize out here, okay, it won't really. Okay, what we can do is if you factorize out a here, will remain with 4a plus 1. And the other side, if you factorize out b, you remain with 4b plus 1. But this will still not get to add up. But one thing that you can deduce from here, let's say I am trying to make a the subject of the formula. I take one of the I get this a, I'll take it the other side. So get that 4a squared is equal to 4b squared plus b minus a. I'll divide through by 4. That will be a squared is equal to 4b squared plus b minus a. And then if I square root so that I just remain with a, you are going to find that a is actually there is a 4 in the denominator here. Remember I said that we are dividing through by 4. So we're going to have that a is equal to, every time you square root, you're going to have positive or negative. So we're going to have positive or negative square root of 4b squared minus plus b minus a. Down, the square root of 4 is a 2, so I can just write over 2 like this. Because a is giving us two results, it means that this is not a one-to-one function. Why? Because a is giving us positive that thing, or a is giving us negative that thing. It's giving us two things, so it's not one-to-one. Is this okay? I'm guessing it's okay since there's no question. Another important concept about function you need to understand is what we call an odd and even function. Anyone to give me examples of an odd number? odd number? Anyone? Okay, 5. So Prudence, that one we could have factorized, but even if we factorize, it will still not give us anything, right? Like it will not give us. Okay, what I could have done here, another route I could have taken is I could have said, okay, let me put those which has got a square together. Could have add 4a squared. I'll take the 4b the other side minus 4b squared. And that would have been equal to the other side would have remained with a b, right? And then I'll get this a, take it the other side, it becomes minus a. And then at this point, what I'll do is that I'm going to factorize out 4. So we're going to have 4, and then we're going to have a squared minus b squared, and that is going to be equal to this b minus a. You know, I can also write it as minus. I'll factorize out a minus, and I'll remain with a minus b, right? You remember this from your high school, grade 12, syllabus D. If I distribute the negative, it will still give me b minus a. Now I've got a squared minus b squared. That's a difference of two squares. So this will be 4. Difference of two squared is a minus b, a plus b. I hope we've not forgotten that math. And that will be equal to negative. We're going to have a minus b. This a minus b can cancel with this a minus b. So we're going to have 4. A plus b is equal to negative 1 there, isn't it? And then here we'll multiply by the we'll multiply through by the 4. That will be 4a plus 4b is equal to negative 1. And we'll take the 4b the other side. So 4 is going to be equal to negative 1 minus 4b over. We are going to have, oh, sorry, I want to make s with the formula, over 4. But because I took this difference of 2 squared, it will deceive you, it because it might appear as though this is a one-to-one function. Okay. So that's, we didn't just want to complicate it like that. So for something that is quadratic or raised to the power 3 or anything that is raised to any power is not a one-to-one function. And the way you want to show that is just try to do the like square rooting so that it gives you a positive and negative, and you tell like that. So I was asking about an odd and an even number. Our friend told us one odd number, a 5. So odd numbers we have got 1, 3, 5, 7, 9, 11, 13. Even numbers starts from 0, 0, 2, 4, 6, 8, 10, 12, like that. So if you have got a function like this, f of x is equal to, let's say, 3x squared plus 1. So this function, if you want to, they ask you to say determine if this function is odd or even. What you do is just look at the powers of x. This is a 1. A 1 means that it is 1x to the power 0. Remember from your high school, any number raised to the power 0, the answer is 1. So x to the power 0, the answer is 1. 1 times 1 is still a 1. So because this is an even number, even 0 is an even number, so this function is an even function because all the terms have got powers which are even. But that's not how you show. You can just confirm that. How you show is that if a function is even, f of negative x should be equal to f of x. This is what you want to show. This is what you want to show. So for an even function, f of negative x should be equal to f of x. So how do you show? What you just do is that for the function that you've been given, where there is x, put negative x there. And so that is going to be equal to, come here again, that will be 3. Where there is x, put negative x. That is squared, right? Plus 1. And this is going to give us f of negative x is equal to 3. Now remember, negative x squared. Any negative number raised to the power 2 is this, the answer is still positive. For example, negative 4 squared is the same as positive 4 squared. In other words, when you get a negative number, you raise it to an even number. The answer will always be positive. For example, negative 2 to the power 2, negative 2 to the power 4, negative 2 to the power 6, it is going to be positive. So negative x to the power 2 is the same as positive x to the power 2. and then plus 1. So can you see that this function is the same as the function that you started with? The function that we started with is what? Is f of x. So where there's 3x squared plus 1, I'm going to put f of x. So it becomes f of negative x is equal to f of x. So now you say, since f of negative x is equal to f of x, this means that the function is even. You've shown that the function is even. Okay, so this is the principle here. And then for odd, let's say if you have got f of x is equal to, say, 2x to the power 3 minus, say, 3x. So you can see power 3, that is an odd number. This x is raised to the power 1. 1 is also an odd number. So since both powers are odd, it means that this is an odd function. But how do you show that? For an odd function, f of negative x is supposed to be equal to negative f of x. Okay, that is what it's supposed to be equal to. So therefore, for this one, what we just do is f, where there is x, we put negative x, and that will be equal to, again, we'll say 2, where there is x, put negative x there, raised to the power 3 minus the 3, where there is x, put negative x there. And so this is going to be equal to, now negative x to the power 3 means negative x times negative x times negative x. If you multiply this, the answer will always be a negative x to the power 3. Okay, because this negative x times this negative x, that will give you positive x squared. That positive x squared times this negative x, it will be still negative x to the power 3. So that negative x to the power 3, if you multiply by 2, it will give you negative 2x to the power 3. And then this negative 3 times negative x, that is going to give you positive 3x. So if you compare the function that I found here with the function that's like this one here, if you compare with the original one, you can see they are not the same, right? So you say that f of negative x is not equal to f of x. This means that the function is not even. So just to go a bit further to show that it's odd, what you simply do is, now this function here, remove a negative, factorize a negative. If you remove a negative from negative 2x to the power 3, you are going to remain with positive 2x power 3. If you remove a negative from positive 3x, you remain with negative 3x. So can you see that this function which is inside here, 2x to the power 3 minus 3x, is the same as the original one? This means that f of x is the same as negative times the original function, which is f of x. So you can see that follows this. So since f of negative x is equal to negative f of x, that means that the function is odd. So if you have a combination of powers, say for example, f of x is equal to, say, 3x squared plus x. Power 2 is even. Power 1 on x is odd. So for a function that has got a combination like this, it means that it is neither even nor odd. But how do you show that? You still say f, where there's x, put negative x. That is going to be equal to 3 negative x squared plus, where there's x, put negative x. So this is going to give you f of negative x is equal to negative x squared. Remember, we said that is the same as positive x. So this is the 3x squared. Positive times negative x, that will be negative x. So is this 3x squared minus x the same as the one on top with the 3x squared plus x? No. This tells you that f of negative x is not the same as f of x. What does that mean? This is not even. So how do you show that it's not odd? Factorize out a negative. So you say f of negative x is equal to, if you factorize out a negative, you remain with what? From 3x, if you remove a negative, it will remain negative 3x squared. On negative x, if you remove a negative, it will become positive x. So now ask yourself, is this thing which is in the brackets the same as the function on top? No, they are not the same, because the 3 is negative, the one on top is not. So this tells you that f of negative x is not equal to negative f of x. That means that the function is not odd. Then what do you conclude? The function is neither odd nor even. That is how you make a conclusion. Is this okay? Have I lost anyone on the way? Have I lost out anyone? Okay. Since I haven't lost anyone, let me talk about something that is very easy. There's something known as a compound function. Compound function. A compound function is you just getting a function and inputting it into another function. For example, you have been given that f of x is equal to, let's say, 2x plus 1, and then g of x is equal to, say, 4x squared minus 2. They say find f of g of x. That's number one. Let's say they've also said find g of f of 2. So what do you do in this case? So for the first one, f of g of x, f of g of x, what we are simply doing is that the second thing to be mentioned, that's the g, right? So we're getting g and putting it into f. Okay, so we are writing first the function f, that's 2, but where there is x, I'll put like this, and then remember it's plus 1. So where there is x in the function f, that's where we're putting g, and g is 4x squared minus 2, so that will be 4x squared minus 2. Okay, and this is going to be equal to 2 times 4, that is 8x squared, 2 times negative 2, that's negative 4 plus 1, and this is equal to 8x squared minus 3. As simple as that. And then for the second one, we want to find g of f of 2. There, there are many ways in which you can do it. So what you are doing is that in the function f, first you can start with this if you want. In the function f, where there is x, put a 2. Okay? So here, where there is x, put a 2. And then the answer that you find now, you put it where there is, in g where there is x. Hope you get that. So what we can simply do is get the function g. Okay, get a function g. So the function g is 4x squared x squared minus 2. This is a function g. But remember, in the function g, we are putting the function f. Okay, so we are putting a function f. And the function f is 2x plus 1. But remember, in the function f, where there is x, we are putting a 2. So we are just getting a 2 and putting it there. This is the meaning. If I want, I could have first found f of 2, like just put 2 where there is x in the function f of x. I'm going to find the 5. After I get that 5, I'll now take that 5 and put where there is x in the function g of x. As simple as that. So this is going to be 4. 2 times 2 plus 1, that's a 5. You can see this is the same like this. It would have been like this. And this is 4 times 25 minus 2. I've already written 25 because 5 squared is 25. And then 4 times 25 is that 100 minus 2, and that would be 98. It's very easy, isn't it? Anyone lost? We are good? Prince Chileshe, are we okay? Okay, good. Nice. Now let me talk about the last thing for today, and we do some exam questions. So we have got what we call the inverse of a function. I know you are saying, inverse, we know those things, we know that. You just say why. Well, yeah, it's as simple as that. So if you have got f of x is equal to, say, x plus 1, they say find the inverse. The inverse for this guy, just where there's f of x, just put y. So that will be y is equal to x plus 1. Take 1 the other side, that will become y minus 1 is equal to x, or x is equal to y minus 1. And then like this, now just change it into f inverse of x is equal to, now where there is y, put x minus 1. Very easy, yes. So another thing you need to know, sometimes they can give you two functions and then they ask you to say, show that the two functions are inverses of each other. So imagine in the exam, they gave you this function and then they gave you this function. They said that show that the functions are inverses of each other. Actually, the way they can give you is they'll just say that, given that f of x is equal to x plus 1 and then g of x is equal to x minus 1. Show that the functions are inverses of each other. To show that they're inverses of each other, if you just get one function you put into the other one, it should give you x. What do I mean? If you find f of g of x or g of f of x. So if it is f of g of x, remember we're getting g, we are putting in f. So in f, where there is x, we have got x plus 1. But where there is x, we are going to put g there. So we are putting g, and g is x minus 1. So this is equal to what? X minus 1 plus 1. So can you see that it has given me x? So if two functions are inverses of each other, if you get one function, you put into another one, it should always give you x. In the exam, if they ask you to show, that's how you show. Okay, as simple as that. Now, I told us earlier that a quadratic function is what? It's a many to one function. So meaning that if I find the inverse of a quadratic function, it's going to be one to many. And we said that one to many relation is not a function. So how do you find the inverse of a quadratic? The inverse of a quadratic is very nice. We do something that we call restricting the domain. Okay, restricting the domain. So let me just do a simple one. I'm going to teach you some more details on finding the inverse of a quadratic when we talk about quadratic functions, because the way we've started function like this, functions itself is a very long topic to actually take you the entire semester, because we'll be talking after the general functions, we'll go to quadratic functions, we'll go to polynomial functions, logarithmic functions, exponential functions, trigonometric functions. So you see how these are a lot. The whole semester is gone. Actually, you even enter into semester 2, you are still learning this, or term 3. So for a quadratic function, f of x is equal to x squared. Let's just do a simple one like this one. Now, if you look at this function, f of x is equal to x squared. If you sketch it, it looks like this. So if you want to find its inverse, you restrict the domain. Domain is a set of x values for which the function is defined. So the x values for this function is going to be defined from here, going this direction, and then from here, going this direction. So you just get a function on the symmetric point where this function is cut into two equal halves. Get the positive aspect of the function. So I'm going to remove this aspect. So I'm going to restrict the domain. Restrict domain. Remember, domain is a set of x values. So I'm just going to be starting from 0 going to the positive value. So I'm going to say 0 to infinity. This is the domain that I've restricted. So if I find the inverse of this function, the way the inverse of the function will look like is like this. So because I've restricted the domain, I've removed this function. Okay, like the inverse function is just going to be the one that is positive, because for the function itself I also removed this part. I know it might be okay, just remember that when you restrict the domain, just try to make a simple sketch of the graph and then just take the positive aspect of the graph. I'm going to teach you how to sketch quadratic functions soon, because that will be the next topic after this. So what you do is just say this is y is equal to x squared. and then make x subject form, and this is the same as x squared is equal to y, square root both sides, square root, square root. Now remember, every time you square root, it becomes positive or negative square root of y. But because we restricted the domain to only the positive values, the inverse, therefore, f inverse of x is going to be also, you only get a positive aspect. Okay, so this is going to be the inverse. Initially, it was supposed to have two inverses, positive root x and negative root x. But because I restricted the domain to only this aspect, like the positive values of x, even the inverse function will only use the one that is positive. I hope that's okay. I'm not going to talk about the much details because I've not taught you quadratics to confuse you. We'll talk about the details as we discuss quadratics. Let's do some exam questions. We have got this one here. For part 1, I'm not answering that because we're discussing this part in the next discussion, okay, about determining the domain and the range of a function. And then part 2 is saying find the composite function f of g of x. So remember, f of g of x, we are getting g and putting it in f. Okay, so f is 2 times x. So where there is x, I'll just put this divided by 3 times x minus 2. And then where there was x, now we are putting g. Remember, g is 1 over x squared. So this is going to become, on top, 2 times 1 over x squared, that is going to be 2 over x squared. And then everything over 3 times 1 over x squared, that is going to be 3 over x squared. Remember, this is minus 2. Minus 2 is the same as 2 over 1. So merge this as a single fraction. 3 over x squared, 3 over x squared minus 2 over 1. I told us to say when you want to add a fraction easily, just multiply these two. Use the butterfly method. 3 times 1, that's a 3. Multiply these two. Negative 2 times x squared, that's negative 2x squared, over, multiply the two denominators. X times x squared times 1, that's x squared. That's a butterfly. So we have got 2 over x squared on top. Instead of me saying over, I'll say divided by. And then down I've got, if I added, when I measured as a single fraction, we've gotten 3 minus 2x squared over x squared. And then this is going to be equal to 2 over x squared times the one on top comes down, the one down comes on top. So this will cancel with this. And the answer is just going to be 2 over 3 minus 2x squared. Okay, we have found that. And then the other one is saying find the inverse of x. So the inverse of f of x, we'll just say y is equal to f of x is 2x over 3x minus 2. Cross multiply, this is over 1. This is going to be 3. Y times 3x, that will be 3xy. Y times negative 2, negative 2y. And that is going to be equal to 1 times 2x, that's going to be 2x. Take everything that has got an x to the same side. So we're going to have 3xy. This 2x will come this side. It becomes minus 2x. The 2y goes the other side. Factorize out x. So we're going to have x. What will remain here is 3y minus what remains there is a 2. And that is going to be equal to 2y. And then at this point, divide through by 3y minus 2 so that you remain with x. So x is going to be equal to 2y over 3y minus 2. Therefore, f inverse of x is going to be equal to, now where there is y, put x, 2x over 3x minus 2. Simple as ABC, right? So what I want you to do is the rest of the questions are your exercise. Let's go. You can screenshot this one. This is your exercise. Given that f of x is 3x plus 1 over x minus 1, find f of f inverse. In other words, get f, you put into f. The answer that you find its inverse. That's the meaning of that. Okay. Now, please take note. This is f of f. Okay, let me answer for you this one so that you just see how it goes. So we're getting f and putting into f. So that f of f, remember this is f of f, inverse of 2. But first we find f of f. That is going to be equal to 3. Where there is x, we'll put 3x plus 1 divided by x minus 3. Remember, it's 3x plus 1. In the denominator, we've got x minus 3. But remember, where there is x, we are putting the same function, 3x plus 1 over x minus 3. And then this is minus 3. Okay? This is a 3 here. Distribute on top the 3. 3 times 3, that is going to be 9x. 3 times 1, that will be 3 divided by x minus 3. Then we have got a plus 1. I'll say this is also over 1. Instead of me saying over, I'm going to say divided by. In the denominator, I've got also 3x plus 1 over x minus 3. Minus 3, I'll say this is over 1. This is going to be equal to, again, use the butterfly method, the 9x plus 1 plus 3 on top, multiply with the 1 down to be 9x plus 3. And then the x minus 3 down, multiply with the 1 on top, that will just be x minus 3. Multiply the two denominators, that will just be x minus 3. And then this is divided by the 3x plus 1 on top, multiply with the x down, that will be 3x plus 1. The negative 3 on top, multiplied by x minus 3, that will be negative 3x plus 9. Multiply the two denominators, that's x minus 3. And this is going to be, can you see that this 3 and negative 3 will cancel? 9x plus x, that is going to be 10x over x minus 3. I'll change the sign into multiplication. This x minus 3 in the denominator will go on top, x minus 3. Down, we are now going to have 3x will cancel with the negative 3x. 1 plus 9, that is going to be a 10. Okay, so can you see that this will cancel with this? So we'll remain with 10x over 10, which is just the x. Now that we have found the f of f, and then we want now to find the inverse of f. So therefore, we know f of x, that is what? An x. To find the inverse of this guy, we will say y is equal to x. Make x a subject formula. So when the function is x, the inverse is also x, because we simply say x is equal to y, meaning that f inverse is also x. Hope you get that. So f inverse of x is equal to x. But here we want to find the inverse with a 2. Now this one is not f inverse, because remember where we substituted y, it was f of x. Therefore, f inverse of x, that's now the one that has given us x. But now I want to put 2 where there is that x. So it means that it's going to just be a 2. That's the answer. Like we're putting just where there's x a 2. Okay, I want you to do this one now. This is your practice. Please screenshot and then send the answers. I'll give you 30 minutes to answer. Let the two functions f and g be defined by, you have got f of x like that, g of x is this one. Show that the function is 1 to 1, show that f is 1 to 1, and then find the domain. Please, for this one, don't answer it. We'll answer it later. Find the domain of f inverse. Find the, you can answer this one, find the composite function, and then you can answer this one. Hence, solve the equation f of g of x is equal to that, and then also answer this one. Okay, hope you've screenshotted. And then this one also, the domain of the function, I want you to answer this one, and I want you to answer this one. Okay, please don't answer the first one, that's a domain, don't answer it. There, are you done? And then you also have this one, find f of g inverse. And then this one, answer everything. We have done everything here. F of f of f. So what you do is first find f of f. Once you find f of f, you come and put it in f. That's the meaning of f of f of f. In other words, it is simply f, and then you find f of f. So find f of f. The answer you get to put it in f. That's f of f of f. Okay, and then the last one here. Given the function that and that, solve the equation h of f inverse is equal to 0. So that is where we end for today. Please answer these questions. I'll be expecting the answers in 30 minutes. Thank you so much.